So, good morning, everyone. Myself, Sunil Nayak. Today, we are going to learn about the probability and random processes. These things are pertaining to the networking concept. While we are learning probability, the application of probability, some basic concepts are really helpful in networking. So, let's start. We are going to start with the introduction concept. We will learn the definition of probability. Later on, we are going to undergo through the importance of networking in the field of mathematics as well as the the electronics and communication. Later on, we will see the basic probability concepts. Let's start with the probability. Now, as the name suggests, the probability means what could be probably to happen. Okay, it's mathematical concept that signifies the which event is to be occurred, like in the networking, what are the events like the failure of the data or some behavior of some network elements will work good or not, whether the connection will be established or not. So these are the various part of the probability, and basically the probability is between 0 and 1. So P in bracket of A is between the 0 and 1. So this is basically the probability of any event A. So let's suppose we have connected a router with our LAN connection, and we have connected the router to our PC. So what will be the probability of getting an internet? So or connecting with the internet. So this could be mapped with the probability between 0 and 1. Now, what is the importance in networking? So now it is a very required in networking because we have to deal with the uncertainties like some we are sending some packets. So packets may be received in proper frames or not. So kind of packet loss will be there. Then there might be some transmission errors. So we have to use some parity bits in that cases in digital circuits as we have learned. But it can also be mapped with the probability that how many times the transmission errors are there and what are the chances in the future that there will be no transmission error. With the help of probability we can get that. Now, the network congestion. So as we all know that we all are using the internet. So sometimes what happens that in a particular area, a lot of people are using internet. So at the same time, the network is congested, the speed becomes slower. So by applying the probability theory, the number of users per area in a certain hours can be mapped, and the probability of receiving an internet or predicting the internet services in that particular area during certain hours, uh, we can model and predict the performance. Okay, and which is right now very important in the network design and optimization. Now, what are the basic probability concepts? So in basic probability concept, we basically starts with the random experiments. Now, what is a random experiment? So it is a process with an uncertain outcomes. Like in networking, as we see, the data is being transmitted, right? Then the packet is being routed, some sort of error in network connections or we can say network failures. These are the random experiments. Okay, in basic mathematics, we had like a tossing of coins. Okay, but in which the outcomes are true or false, like head or tail, but it will uncertain. Any of the one can be occurred. Now, what is a sample space? So the sample space is the number of possible outcomes, like head and tail, as I told previously. Now, an event. What is an event? An event is a subset of the sample space, like tossing of a coin. Okay, tossing of a coin. So it may be fetched with the head or it may be fetched with the tail. So head and tail are the subset that is called as an event. Okay, so getting an event like getting a heads in the toss, that is called an event. Now, what is the probability of any event? So let's suppose what will be the probability of getting a head while I am tossing a coin. Okay, so probability of the event is the likelihood of that particular event. Okay, it is computed as the ratio of the number of favorable outcomes to the number of possible outcomes. So let's suppose favorable outcomes is head, but the total number of is head plus tail. So 1 by 2 probability is called zero point 0.5. So that's why the getting the head outcome, that is called as a 0.5, because 1 by 2, because either it will be head or it will be tail. And as long as the total number of favorable outcomes are increasing, or total number of outcomes are increasing, the probability concept gets deeper insight. Now, modeling uncertainties. So networking environment are really not in a regular pattern. Okay, so like multiple factors affect this, like transmission delays, loss of some packets, and network traffic. These are unpredictable, as I told previously. Like in peak hours, it is very unpredictable. Okay, so probability concept allows us to model and analyze these uncertainties to make informed decisions, like uh, how network can be designed in peak hours, and which methods can be used to model uh, these uncertainties, to cope up with these uncertainties, which methods can be used uh, for decentralizing the network congestion, so we can manage it properly. Now the next topic is a performance analysis, which is very important, because to assess the performance of any local area network or computer networks, so we have to quantify the various events occurring. Okay, so probability helps us that calculate that those metrics, like network throughput, like what is the maximum amount of data that can be given through the lane networks, or computer networks, like at which latency they are providing. The reliability, obviously reliability is a very important in performance analysis. Okay, which are very vital for optimizing network performance, because we have to create a redundant system for this performance analysis. Now the risk assessment. Okay, so risk assessment is like, we know that we deal with the uncertainty in the network, but what happens if there is a risk? Okay, so dealing with the risk. So first of all, we have to understand the risk priority, uh, the risk urgency, or what we say as a risk strength, like which methods, or how in how many ways we can cope up with the risk. Okay, so so we can define the risk priority and its urgency in order, and probability can be assigned with each and every level of risk. So at a certain amount of time, or at a particular time, we can come to know that at this particular time, this particular level of risk can be there in this amount of percentage. So we can be ready to cope up, and we can design the robust and secure networks. The next level of importance is the traffic engineering, which is a really tougher in the metro cities and mega cities nowadays, because the data we see in the peak hours, we have to wait 20 to 30 minutes on the road. Okay, so by applying these probability models, the network administrator can manage the traffic efficiently, because right now we know that uh, the the traffic network can be easily handled with the computers, as those traffic lights are network connected. So we can reduce the congestion in the real time problems like traffic engineering, and improve all the GPS users. Now the next importance we encounter is the quality of service. Okay, so far as the network engineering is concerned, the quality of service is a way more important, because what we experience in the networking and communication issues, like jitter and packet loss, are inherently probabilistic. Like sometimes what happens that we get internet, right? But when we are going to download such things, like we are working on a servers, but if some sort of jitter or packet loss is there, the server connection is discontinued. So again, you have to authenticate your server with your credentials, and you have to reconnect. So this quality of service can be mapped with the probability that which quality of service the service provider are providing. Okay, so so in VoIP or video streaming, it is way more important, or it is very important in the real time application as well, while we are working on servers with the sensors data on very huge projects. Now the next importance, that is the resource allocation. So efficient resource allocation is critical in networking. Means that how many resources we are allocated in we are going to allocate in the networking. It is way more important. Why? Because how many bandwidth needs to be allocated, which routing paths that are to be required. Apart from that, load balancing and optimal resource utilizations. These are the methods we can allocate the resources to provide a quality of service and to reduce the packet data loss, to reduce the uncertainty, to manage the risk accordingly. And the final one is the fault tolerance. Now, fault tolerance is a very important. Why? Because while designing the networks, we have to understand that if this fault is happen, or if that fault is created by certain conditions, okay, so your network should be tolerant to cope up with that particular fault. So that is an inherent characteristic we have to deal with. So for that, the possible outcomes of hardware failures that we have to make list out, or link disruptions, that you have to understand. And the network architects can create these backup plans or redundant systems for that strategies. There are various strategies for that fault tolerance as well. Now, basic probability concept. So as we know, what is a random experiment? So we know that there are certain outcomes of any experiment. Okay, so in networking, we come up with the data transmission, the packet routing, network failures, packet loss, etc. Okay, so these are the very random experiments. So sample space, as we have discussed, like head or tails. Okay, so the possible number of outcomes in one particular group, that is called as a span, the possible outcomes of that, right? And event, as we already have discussed, like the possible outcomes that happens, then that becomes an event, right? And probability of that already we have discussed. Now what are the complementary events? So complementary events, all the outcomes that is remained after the event has been done. Like let's suppose the head is there. So what is the complementary event? The tail, that is 1 minus p of a. Now what is an addition rule? Like we can create a space, like when we add two events, it becomes an addition, that becomes a space, like p of a union b is pa plus b, that we all know that if we add two events, it becomes a space, sample space, because these are the only two events that makes the space. So basic probability concepts. The example is head and tail, very simple example in which the two probable outcomes are there, head and tail, which creates a space. The event A is equal to head, and A dash is equal to tail, because it's a complementary event, right? So probability of heads, that is a zero point 0.5, as we know that the event upon total outcome, that 1 upon 1 plus 1, that is 1 by 2, is 0.5, right? So using the addition rules, we can get the probability like P of A union A dash is equal to P of A plus P of A dash is equal to 0.5 plus 0.5 is equal to 1. So this demonstrates the fundamental principle of probability.